All right, so this is part 2 of rate of change. Yesterday we talked about the big thing you want to take away from rate of change is basically how to find it, right? Rate of change is kind of like a slope if it was a straight line. And it is there. Okay, so it would be f of the second number minus f of the first number over second minus first. And really, order doesn't matter. It could be reversed as long as you're consistent with the top and the bottom. So if I want to find the rate of change, there's a lot of different ways to do it. I could find it from a chart, right? I could pick information. We did that. I could find it from an equation. I could take those values and plug it in. Yesterday we learned how to use your graphing calculator to set up the y equals, which was, it's going to be a huge tool when it comes to things that get more complicated. Today we're going to do something that's a little bit more tedious, I would say, and being able to understand your graphing calculator is definitely going to help you out, okay? We talked about the positive and negative rates of change. So I want to talk about this again because the language from 1-1 should now get like blended in with 1-2. And by way of, if you think about the questions that could get asked about a graph, it could ask you if, so I did this yesterday, but I'm going to do it again. I could ask you if the original graph is positive or negative, where the graph is positive or negative. I could ask where the graph is increasing or decreasing. And then I can ask those same things about your rate of change. Is your rate of change positive or negative? Or is your rate of change increasing or decreasing? And 2 of these actually mean the same thing. The rate of change is positive when the graph is increasing. And the rate of change is negative when the graph is decreasing. Those things mean the same things, just in different words. So positive and negative, this would be above the x-axis, below the x-axis. Those values would be physically positive or negative when we're looking at the y values. For increasing, and the graph is increasing, or the rate of change is positive, then on my function, my graph is literally rising as you move from left to right. So from here to here would be where the graph is increasing, and it is also where your rate of change is positive. The graph is decreasing, the same place your rate of change is negative. So if I went like this, then from here to here, that graph is decreasing and your rate of change is negative. And then the last one is concave up and concave down. If the rate of change is increasing, it's concave up. It makes the U shape. And if it's decreasing, then it is concave down. And it is decreasing. And these types of questions will get you by way of changing the language from is the function increasing to is the rate of change of the function increasing. And those mean different things. And it's literally 3 little words that change it. Okay? It'd either ask is the graph increasing, or it will ask if the rate of change of the graph is increasing. And this will happen now in a little bit basic functions, or it will happen all the way to the last section we talk about, which is polar before your exam. They will still use that same language. So you've got to make sure you really understand it. There will 100% be questions about rate of change on your AP exam in multiple ways. So it's really important that you can grasp this. So on Tuesday's quiz, you got to make sure you see that language and you know what it's asking, okay? It could ask for any of those 8 things, really. Graph is positive, graph is negative, graph is increasing, graph is decreasing, rate of change is positive, rate of change is negative, rate of change is increasing, rate of change is decreasing. Or it could say concave up or concave down. Any of those, you would have to understand what it means. All right, so then we went through a couple examples. We talked about how to use the chart. We talked about how to find where this would be where's your max and use your graphing calculator. And we're going to pick up here on example 5. So example 5 says function f is given by f of x equals negative 3x squared plus 7x minus 1, and it wants you to estimate the rate of change at 2. So I'm going to graph this just so that we have a visual on it, but you don't need to graph this to do this. It will help you when we go to do the next step to have it in your y equals, but I'm going to show you what it looks like. All right, so I'm going to plug it into my y equals. I'm going to do negative 3x squared plus 7x minus 1. Okay, now I want to know the rate of change at 2. That did not give me an interval, right? So I can't do f of the second minus f of the first over the second minus the first. If it gave me an interval, I'd just plug those things in. I'd use my calculator. If it gives you a point, and I'm going to try to get as close on this as I can. Actually, let me find where 2 is. I'm going to go where x is 2. Okay, I'm going to stop recording just so that we can talk about what this means, right? So on this specific graph, the 2 is like here, okay? And again, I can't figure out the rate of change on a single point. Eventually in calculus, start to learn about a tangent line, all these things, we're not there, okay? So what we're going to do is, notice that the directions say estimate. We are going to estimate the rate of change by using a point that is very close to this, but not this point. So if I picked a point like over here, right, like say like, I don't even know what number this would be, but if I picked a point there and I drew a line through it, I could find the slope of that line, which would give me the rate of change. And then if I were to move closer and closer and closer and closer to that point, I'm going to get closer and closer and closer to the rate of change at that physical point. So the goal is to grab an x value that is very close to the one that you have and use that. Now you could go in either direction. So I could use 2 and I could use 1.99999, something like that. Or for the sake of us all having the same thing, we're going to pick the same value, which is 0.001 bigger than what we have, okay? So I'm going to say my x2 is going to be 2.001. And again, you could pick a point very close to it that is less than it. You could pick a point that is 0.00001. And the more zeros that are there, the closer it is to that point, the more accurate it's going to be. But so that we all get the same answer here, we're going to pick that one. So we're always going to go up 0.001. So then I'm going to do f of 2.001 minus f of 2 over 2.001 minus 2. And I'm going to let my calculator do all that work. So I already have the y equals stored. So then from my regular home screen, I'll show you what this looks like, but I'm going to type it in. I'm going to hit second y equals to get the fraction. Second trace to get the y1. Open the parentheses, 2.001 minus, not second, I keep saying second, but it's alpha. Alpha trace gives you the y1 again of 2 over 2.001 minus 2. So it looks like this. In my y1 goes the f of x, this equation here. Yeah. So you should have gotten negative 5.003. This, yep. Yep. Yeah. Okay, so first of all, in your y equals has to go your equation. So I put my y equals the negative 3x squared plus 7x minus 1. And then I go back to my regular screen. So second mode, or quit, gets you back to that regular screen. What's one of the ways? Now I'm going to do alpha y equals, and that brings up my shortcut for my fraction. Remember, some of you have it on the button next to the alpha, the variable button, but I don't. I have to use this one.
It's 1, right? The n over d. Like, which one do I choose? 'Cause there's
Oh, yes, n over d, yes. Okay, then I do alpha trace, and that brings up my y menu. I only have one in Y1, so I'm going to do Y1. I'm going to open my parentheses and type 2.001, close my parentheses. Minus alpha, trace again, go back to that Y1, open the parentheses, 2. You don't need to close the parentheses at the end, but if you want to make the habit of it, go for it. Arrow down to go to the denominator. 2.001 minus 2. And there's your rate of change. Okay. Now you could have taken negative 3x squared plus 7x minus 1, plugged 2.001 into both the x values. You would have gotten the same thing. You just have to do it piece by piece. It is way easier to do it all in one step. And again, quiz, you'll need to know how to do rate of change given values that you can actually plug in. So kind of like what we did, like numbers 1 and 2 on the homework. Questions? Okay, you want to get good at that process because it's going to be something that you can use sporadically throughout the whole year and it will help you. So my rate of change is negative 5.003. Now let's say we repeat that whole process and we use that like 1.999, whatever it is. You're going to get something close. It might even round to the same number. I get negative, here, this is what I get if I change it. If I use 1.999 instead, it's close to it, right? It's like 0.006 off of it. It would round to the same whole number, but for purposes of us making sure we get the same answers, we're going to go up. Does that make sense? Yeah? Okay. All right. Example 6. Now we're back to a graph. It says the graph of the function y equals g of x is given. What's the average rate of change on the given intervals? So now I'm going to use my graph. So the first one is from negative 3 to negative 2. So x is negative 3 here, and x is negative 2 here. If I could physically count it, it would be easy to just count it, like if it was perfect. Like this one is only 1 unit over. So if I wanted to just count my vertical change from here, it's 1, 2, 3, 4, and a little bit. It almost looks like 4 1/3. It's a little bit less than half. So it could be 4 1/3 over my rate of change horizontally, which is 1. You're not going to leave it like that, though. You would put this into an improper fraction, and this would be 13/3. If I used the actual physical points, then I would say one coordinate point is negative 3, 0, and one coordinate point is negative 2, and we're going to say again, that is 4 1/3. So then my rate of change would be 0 minus 4 1/3 over negative 3 minus a negative 2, which becomes plus 2. And I get negative 4 1/3 over negative 1, gets me back to the 4 1/3, gets me back to the 13/3. So you can do it either way. You could physically count your rise and your run, or you could use the 2 coordinate points. Sometimes it's easier than others. If you look at B, I'm going from 0 to where x is 0 to x is 1. What would be the rate of change there? 1. Positive 1. Up 1 over 1. If I go from 1 to 2, what would be the rate of change there? Negative 1. You're going down 1 and right 1. Questions so far? Okay, last one, and I don't know if I did it on yours, but we need to change the wording on this because it's not going to ask for what's the actual one. It will ask which month, something like this, has bigger change, something like that. It could say which one increases more. It could say which one decreases more. Which one says rate of change is bigger, something like that, okay? So it says the daily high temperature at a certain point in a river is modeled by a graph. Each point on the vertical grid line indicates the temperature in degrees on the first day of the indicated month. So we're going to compare July with September. So if I go to my graph, July starts here. That month would end where? How do I know where July would end? Right before August starts. So this is going to be what I'm looking at as far as rate of change goes. Then the next one is September, and September starts here and it stops here. Without specifically getting points there and estimating, I could literally just compare those two segments and see which one is steeper. Which one is steeper? September. So it has a negative change, right? If it said which one has the greater increase, well, that's July. Which one has the bigger decrease? That's September. Which one has the bigger change is September, because we ignore whether it goes up or goes down. Does that make sense? Questions? That's it. Okay, we do have to take care of a couple things. One, I need you to make sure you have this class in your Sarah app. Okay, so we have two tasks before we leave. The Sarah app, you have to add my email. I'll spell it for you, which is MCHRISWISSER at McCarthyHigh.org.
Is the homework a PDF?
The homework is a PDF and the classroom. The classroom, I think, has 6 questions. And this time there's work.
Can I just put AP Classroom like on the corner of the PDF?
Sure. Yeah. And if you ask for a locker, I have your locker for you.